Okay, repeating what we covered as we began classwork 5.7. Ultimately, we are going to graph this rational function that we see here. Before doing that, I had everyone find the x-intercepts. X-intercepts are what happens when the numerator is 0. So I've got the equation for numerator equaling 0. We factored it, and then we got our two solutions. Now we're setting that aside. And I had everyone do polynomial division of this numerator divided by this denominator. And we ended up getting that the function that we are ultimately wanting to graph is an entire quotient of 3 plus, and then a remainder that didn't get divided. Now what we're going to do is we're going to focus on just the remainder over the divisor, and we're going to graph that on its own. And now I'll give away the little secret. What does this tell you to do to a graph? What does that 3 plus? Yes. Now, with this function here, you have a numerator whose degree is less than the denominator's degree. What does that mean as its horizontal asymptote? The horizontal asymptote of just this function is 0. And again, it's because the numerator degree is less than the denominator degree. Now, if we take that and move it up 3, guess what the horizontal asymptote is going to be on the ultimate function we are trying to graph? You got it. So what I'm wanting you to do today is use polynomial division to start to peek into a secret about finding horizontal asymptotes. And oh, it is recording. I've got this little thing that says I'm recording, and I just moved it off screen. That's why you didn't see it. Oh, it sometimes shows up. I don't know. Sometimes I click things and it shows up. I don't know. Anyway, so we've got horizontal asymptote of y equals 0. Now, the x-intercepts are found by looking at what makes this numerator equal to 0. It's not the prettiest thing, but we're at least getting some information. So what causes negative 4x plus 33 to equal 0? What lovely number? And it's okay if you just write it as a decimal. As a fraction, it's 33/4. What is that as a decimal number? Anyone? Yay, thank you. 8.25. I'm going to come over to the graph and plot 8.25 approximately. And that is my only x-intercept. Now, vertical asymptote. Vertical asymptotes are found when the denominator is equal to 0. Can you nicely factor x squared plus 4x minus 12? We need two numbers that multiply to make negative 12. And when you add them, you get positive 4. And, there we go. Thank you. So I have x plus 6 and x minus 2. And that tells me my vertical asymptotes are negative 6 and positive 2. So what I'm going to do is I'm going to draw those vertical asymptotes that I just found. Ooh, I can draw lines on this. So I'm going to draw a line at x equals 2. You're actually you subtract the 33 over first. Yeah. And I think there's a way to make these dashed. Oh, fine. Be that way. Anyway, this line is going to be far better than anything I'm going to draw. But it's not where I want it to be, so maybe I should delete it. All right. I'll do it by hand drawing. It's not as good, but whatever. New. And then negative 6. New. I'm also going to draw the horizontal asymptote that is y equals 0. Okay. And I want to emphasize again that we have this one known point. We can cross horizontal asymptotes. That happens often. Now, for the sign line, you are putting down any numbers that make the numerator or the denominator 0. That would be negative 6, positive 2, and positive 8.25. And then like we did on Friday, we're going to figure out for each of these 4 sections, is it positive or is it negative? That means I'm going to pick some number larger than 8.25. Just anything larger. Personally, I would go with 10. And this is my testing number. It's going to be easiest if I plug it into a factored form of my fraction. So my fraction over here, the numerator can't be factored, but the denominator is factored, and we saw what it was factored to. And in this format, it's going to be easier to work with. Now, if I plug 10 into this x, do you see that the numerator is going to be negative? And then if I plug 10 into x plus 6, I will get positive. 10 into x minus 2, I'm going to get positive. So I have a negative number divided by a positive number. That tells me that this graph exists underneath the x-axis when I am greater than 8.25. And let me tell you what that tells us about the graph. If I have a negative, if I'm under the x-axis along here, and this is heading out to x's that go to positive infinity, my graph must follow the horizontal asymptote. So basically it looks like it's crossing the x-axis, Now, we're not going to see it in the graph very well from the actual graph when we look at it. But basically, it's got to come down, and then it's got to come back up to this asymptote because it must follow the asymptote, and I know that it only exists where it's negative after crossing that x-axis. You're really not going to see the dip very well in the actual graph. You just know that it's coming from underneath because of the work we just did. Now, let's check some number in this interval. Pick any number between 2 and 8.25. I'm looking for your choice. 5 is a good number. It's a nice number to try. So I'm coming back over here, getting rid of those. Whoa, I dropped my pen. Now, if I'm working with positive 5 plugged into this x times negative 4 plus 33, do you see that it's positive? And then positive 5 plus 6, positive 5 minus 2, everybody's positive. So this tells me that between x equals 2, which is a vertical asymptote, and 8.25, which is an x-intercept, I am only above the x-axis. I'm going to erase this highlight out of the way and then point out that that is telling me that I am existing only along here. I must follow the vertical asymptote on its right side. This forces me to have to, on the right side of that vertical asymptote, head up. And then I can just kind of connect it to that x-intercept. And voila, I've got a bit of the graph going. Now I'm going to erase that highlight. Put that asymptote back in there. And now let's check another section. Pick any number between negative 6 and 2. There's a very good choice to be made. What is a really good choice? 0. So now I'm going to plug 0 into each of these x's. Plugging 0 into x in the numerator, I'm ending up with a positive 33, but positive is all that matters. In the denominator, 0 plus 6 and 0 minus 2. So I've got a positive divided by a positive and a negative multiplied. So ultimately, I have a negative number. All my y values are negative when I am between my two asymptotes. So that means that on the left side of x equals 2, I have to be heading down. On the right side of negative 6, I have to be heading down. And somewhere it reaches a high point and comes back down without crossing the x-axis. Part of finding those x-intercepts is knowing when you can and cannot cross this line. Now, if I wanted to get a better looking graph, I could plot some easy to calculate points, which is questionable actually with this. Oh dear. If I wanted to, I could plug 0 into x and see that my y-intercept is 33 divided by negative 12, but that's not the nicest number in the world. I'm not going to ask of you to find that y-intercept. For the sake, though, of the fact that we're drawing this, what is, if I plug in 0 for x, my y is 33 over negative 12. So let's see, what is that? That's negative less than 3. Does that sound good? Negative of something less than 3, between -2 and -3. So somewhere around here-ish. No, stay. So that helps me to get an idea. At this point, allow your creativity to flow a little bit and guess what the graph might do if it is forced to stay under the x-axis and asymptote. You're not expected to know exactly where it hits its high point. Now, I'm going to erase or try to, ooh, there we go, good. We still have another section to check. So, what would be a nice number to check that's smaller than -6? I know what I want to choose. I'm going to choose -10 because it's easier to look at than -7. But you can pick any number smaller than -6. And now, if I plug in -10, the numerator is going to show up positive because I've got -4 times -10 plus 33. If I plug in -10, I can see x plus 6 is negative. I can also see x minus 2 is negative. So in the denominator, I'm multiplying two negatives to get a positive with a positive numerator. And now I know that I exist above the x-axis when my x is smaller than -6. So that is telling me that I exist along here. To the left of my vertical asymptote at -6, I have to be heading up the asymptote. I do not have any other x-intercepts, so I have to stay above the asymptote completely. Now, I don't know exactly what my graph looks like in between here, but it should just be a fairly smooth curve attempting to connect to itself. So, I get this. And I will show you in a little bit what the actual graph looks like, but let's finish this problem first. Because now I'm moving on to number 4, which was ultimately where I intended to go. So know that what I'm doing is I'm giving you one problem per page. Your goal is ultimately to figure out how to graph this rational function. So we're looking at how to graph rational functions when the numerator and the denominator have the same degree. That's ultimately what we're doing today. But we're going to make some conclusions tomorrow because first you need to learn this and play with it. All right, here we go. Now, if I look at the work done in part 1 or number 1 and 2, I found x-intercepts of the function I'm trying to graph. I also know what this graph looks like, and I know that +3 means move it up 3 units. So I'm going to start by plotting these two x-intercepts of 1/3 and -3. 1/3 and -3. Then I'm going to take points that I found in this graph and move them up 3 units. So I have that 8.25. We're going to keep that x coordinate 8.25, but move it up 3 units, 1, 2, 3. The horizontal asymptote on the graph that we are moving up 3 units was 0. So now I have a horizontal asymptote of 3. And I'm going to draw that in. Will the vertical asymptotes change at all by moving a graph up or down? Are the vertical asymptotes going to change by moving this graph 3 units up? And I'm hoping that you're still there. Are my vertical asymptotes still going to be at -6 and 2? Correct. They will still be -6 and 2. Now, I've got enough information to take the graph that I had over here and move it with moving it up 3 units. So basically, I know it's going to down here just kind of go like that. I know that this piece is going to look pretty much the same, just up 3 units. And I'm not drawing perfectly, I want to remind you. And then this piece moved up 3 units. That's not fantastic, but yeah. Now I want you to be forewarned. You are not going to necessarily be able to see this dip and coming back up. You just need to be aware that the graph has to do that. I'm going to show you what the actual answer looks like. Do you see that you can't really see the dip that I drew? And I don't expect you to necessarily show that. So those x-intercepts in number 1, I plotted those points. And I plotted more points than I expected you to come up with, but I thought I'd add in a little bit. So these 2 points are the x-intercepts found in part 1, or problem 1. This was the x-intercept before I moved everything up 3 units. So those 3 points in particular, you can plot. You could have plotted the y-intercept of the graph from problem 3, but you didn't have to plot this y-intercept because I didn't specifically ask for it. The reason I didn't ask for it was because it's such a horrible number. And also, this number line makes it so that I really don't need to plot very many points to get the idea of what this function looks like. So, very important. Understand that by moving the graph up 3 units, we went from a horizontal asymptote of 0 to a horizontal asymptote at 3. And also, as we move up 3 units, the vertical asymptotes did not change. We also know that the horizontal asymptote does get crossed right here. We had an x-intercept before we moved the graph up 3 units. That allowed us to know a little bit more about the graph's behavior and helped us to understand that it's technically under that horizontal asymptote. And that's a hard thing to find and notice. So the question is, what is the most important thing I want you to notice? The asymptotes and the x-intercepts. Those are the most important things that you need to get out of this class, is just understanding how to find those vertical asymptotes. We're going to soon make a conclusion, but not until tomorrow, about finding the horizontal asymptotes. And we already know how to find the x-intercepts. Today's quiz, just to repeat myself a little bit, today's quiz is going to be, I give you problems like one of these four, and I'm going to only ask you for x-intercepts, y-intercept, vertical asymptotes. That's it. Those are the most important things of everything that you are learning about graphing that you need to take with you. And you need to take with you an understanding of the fact that the graph must follow the asymptotes. When you have a horizontal asymptote, you have two ends, a right end and a left end, and it must head toward that asymptote. Every vertical asymptote has a left and a right side. And you have to know with each vertical asymptote, the left and right sides, are you heading up or down with each of those individually? And so I'm hoping that that makes sense. And I've got another problem for us to go through together. We're going to go through it a little bit faster. Then for your homework, you're going to do two more of these problems on your own. The homework is just what we're doing in classwork, exactly those things. And you just are going to try them out on your own after going through two of these together. Okay, so I'm going to go faster through this one, and I need to make sure to give you enough time for the quiz. So know that if I don't get all the way through it, I do have the answers available for you to look at. Okay, here we go. Ultimately, we're going to graph this function. I'm first having you set aside the x-intercepts. So x-intercepts are whatever makes the numerator equal to 0. And you can either factor, or you can solve for x by isolating it to get plus or minus 2. These are going to be the ultimate x-intercepts of the final graph, way down here, when I go to graph this. So I'm going to plot those right now. Positive 2 and negative 2 are x-intercepts of this function. Now, I'm going to take that function and use division to get a quotient, and then have the remainder be a lesser degree polynomial than the divisor, which is the b of x. So getting ready, I'm dividing by x squared plus 6x plus 5. My numerator polynomial starts with an x squared. Now, what goes here? Good. We're looking at x squared times what is x squared? And then 1 times 6x, 1 times 5. And now I've got to figure out what the remainder is. Once my quotient has its constant term, everything to the right of that line I just drew is part of the remainder. I already have my x squared. I have no x's in here, so I need 6x to add to something to make 0 x's. That means negative 6x. Then for my constant of the numerator, I need to get negative 4. 5 plus what gives me negative 4? And I'm hoping you guys are still with me. 5 plus what gives me 4? Not quite. Yeah, it's not the most enjoyable subtraction. Oh, nope. Yeah. Negative 4. So now I have my remainder. When I say what the answer to the division is, the answer to the division is the quotient plus the remainder divided by the original denominator. And then what we're going to do is focus on the aspects of graphing this proper fraction. Proper fraction meaning the degree of the numerator is less than the degree of the denominator. We're going to graph that, and then we're going to move it up 1 unit. So here, starting with just the negative 6x minus 9 over x squared plus 6x plus 5. X-intercepts are what makes the numerator equal to 0. Negative 6x minus 9 equals 0. When x is equal to, add the 9 and then divide by negative 6. So negative 3/2. Let's go with negative 1.5. Write it as a nice decimal number. And I'm going to put that x-intercept down. Vertical asymptotes are what makes the denominator equal to 0. And I'm factoring two numbers that multiply to make 5 and add to make 6. And I find that I have negative 1 and negative 5 as my vertical asymptotes. So I'm going to draw those. Negative 1 and negative 5. Because the numerator is less degree than the denominator, the horizontal asymptote is y equals 0. Then the number line. The sign line is based on anything that makes the numerator or denominator 0. So that includes negative 1.5, negative 1, and negative 5. And then I need to pick numbers. So I'm just going to pick them fairly quickly. If x is greater than negative 1, 0 is a good choice. I'm going to look at a factored form of this polynomial, or the denominator polynomial. because it is a lot easier to determine positive, negative. So plugging in 0 into x, the numerator is negative because it's negative 9. The denominator has 2 positives multiplying. So I've got negative there. I don't tremendously want to plug in a number between negative 1 and negative 1.5. So I just need to know positive, negative. So let's take this one at a time and see if we don't have to calculate as much. Because the best I'm going to be able to do is use like a negative 1.2 or 1.25, something like that. So let's look at the numerator. That's going to be kind of the tricky one. In fact, maybe I want to I realize that this is not pretty. If you threw this in a calculator, you have negative, well, actually, now I'm talking to myself. Negative 6 times negative 1.25. And then minus 9. These two are going to be a positive number. The question is, if I multiply 6 and 1.25, is it bigger than 9 or smaller than 9? So here's where I would say, feel free to use your calculator, because this is just not pretty. And if I had written this decimal number as a fraction, it would be negative, let's see, 1 1/4 would be 5/4. That's still horrible. I said, wait, what do you mean I said 4, not negative 4? That must have been a really long time ago. Oh, okay. Oh dear. And I'm at 5 minutes left. So if you get a calculator out and you tackle that, that actually is going to, I'm about to lose my time here. So this is what the sign line then ends up being if we continue on this process. I'm hoping you're getting the idea of what to do. And you can plot the y-intercept, but it's not pretty, so you don't have to. But that x-intercept of negative 1.5, we know that we want to plot it. We know that we have this horizontal asymptote. Then we move it up 1 unit. And I want to just kind of show real quick, I have a horizontal asymptote of y equals 1. And it is through the understanding of this graph having a horizontal asymptote of y equals 0 and the sign line that I understand the behavior of this function with relation to its horizontal asymptote at 1. So because I'm dealing with only positive to the left of negative 5, I am above that horizontal asymptote. Because I am negative to the right of negative 1, which was my vertical asymptote here, I have to stay under the x-axis, so I have to stay under that horizontal asymptote. And that allows me to know I am completely above the horizontal asymptote, completely below the horizontal asymptote over there. And I know that I crossed the horizontal asymptote at negative 1.5 because that was an x-intercept when the asymptote before it moved up 1. So I'm hoping this makes a good amount of sense to you, and I've got to throw the quiz at you.